Foundations of Amateur Radio. It is in my nature to ask questions. It's been hammered into me from an early age, and it often brings me new friends, new ideas and new projects. After spending quite some time mulling over my understanding of radio, I came up with this question. Is it possible to build a single radio transmitter that is capable of emitting a whisper signal at the same time on all the HF bands? Before we look at the hardware, let's contemplate for a moment what this transmission might look like. Imagine a whisper transmission as a normal audio signal. It sounds like a couple of warbling tones for 2 minutes. Unpacking it, the audio signal is about 6 Hz wide and sits somewhere between 1400 and 1600 Hz. If you were to draw a power chart of this, displaying the frequencies horizontally and power vertically, you'd see a completely flat chart with a little spike, 6 Hz wide, somewhere between 1400 and 1600 Hz. Using an analog radio, you can play this sound into the microphone or audio port, and the radio takes care of transmitting it on the 10-meter band as a 28 MHz beacon. Tune the radio to 40 meters, and it appears as a 7 MHz transmission. The two takeaways are that the whisper signal itself doesn't change between bands or transmissions, and the radio does the heavy lifting to make your whisper transmission come out at the right frequency. Your radio is moving the audio frequencies to the correct amateur band. The electronics in your radio achieve this move by mixing the audio and the tuning frequencies together. If you imagine a 28 MHz whisper signal coming from your transmitter as a power chart, it's essentially silence, except for a little whisper peak somewhere just off to the right of 28 MHz. From a mathematical perspective, the frequency mixer in your radio is performing a multiplication. And best of all, you don't need a radio to do this. You could use software to multiply frequencies instead, and end up with something that represented their product. If you were to create a power chart of this equivalent multiplication, you'd see a completely flat chart with a little spike near 28.1261 MHz. Sound familiar? It gets better. You can store the result of this calculation in a file as a 28 MHz whisper signal, and you could do this as many times as you want. You could create a file with a 3.5 MHz whisper signal, one with a 7 MHz one, and so on. Since we're talking about shuffling numbers only, you could combine all these calculations and end up with a single file that had several whisper signals inside it. The chart picture is again mostly silence, just with little whisper peaks at frequencies suitable for, say, transmission on the 80, 40, 15 and 10 meter bands. Now, all you need is to find a device that's capable of transmitting it. Turns out that we have such a device. A Pluto SDR, a software-defined radio which I've spoken about before. It's capable of transmitting a 56 MHz wide signal, more than ample for what we're doing. We don't need to use the Pluto SDR to calculate the combined signal either, since we can do all that in advance because, as I said, a whisper signal doesn't change. So essentially all we need to do is generate a file that has all the whisper signal information at the right frequencies and send it to the Pluto SDR to transmit. There are a couple of hurdles to overcome. When you multiply two frequencies, you end up with two peaks, one at the sum of both frequencies and one at the difference between them. One you need, the other you don't, so we're going to need to filter this out, something that your analog radio circuit also does. Another challenge is around sampling rates. The Pluto SDR needs a specific sampling rate and bit depth, so we're going to have to generate our file just so. I'm going to skip past complex numbers and move on to power output, since all the power from the transmitter will be spread across all of the combined whisper signals we're attempting to transmit, so we're likely going to need amplification. There's also the matter of testing before we actually connect this contraption to an antenna, and I've glossed over one minor but essential point: the Pluto SDR doesn't do HF. So where does this leave us? We can build a proof of concept using 2 meters and 70 centimeters. Both those bands are native to the Pluto SDR. I'm currently working on generating the actual whisper signal file to start the transformation process. A friend has some testing gear that could allow us to see what's coming out of the transmitter without polluting the airwaves. And of course at this point this is all still what if. I've not actually made this work, but it's keeping me entertained, and that's half the fun. It gets even better. The Pluto has an FPGA on board, so theoretically at least, we might be able to generate this actual file inside the Pluto in real time, which opens up a whole other avenue of exploration, but we'll start with crawling before running. If you have thoughts on this or any other aspect of the hobby, please get in touch. You can send email to cq@vk6flab.com, or you can find me on Twitter and Reddit with my call sign. In the meantime, you know the drill. Get on air and make some noise. I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.